welcome to Monochemistry. Today we're going to look at Electron Configuration Part 2, filling the subshells. Last time we learned about the subshells, now we're going to learn how to fill them properly to be able to write electron configuration. So the question is, write the electron configuration for aluminum. The very first step, step 1, is to determine the total number of electrons. And of course, to do that, you're going to use the atomic number. Aluminum is atomic number 13, so therefore it has 13 electrons. It's pretty handy. In order to fill the electrons properly, you must know the following information. Number 1, the first energy level, we'll represent that as L in the future, has an S subshell, which means it can only hold 2 electrons. The second energy level has an S and a P subshell, so it can hold 8 electrons, 2 plus 6. The third energy level has an S, a P, and a D orbital, so it can hold 18 electrons. Remember, the D orbitals can hold 10 electrons. And the fourth through the seventh energy levels, we'll talk about that later, have S, P, D, and F orbitals, and they can hold a maximum of 32 electrons. Now, here's a hint, a very good hint. The period number of the element is going to equal the number of energy levels the atom has. So if we look at aluminum, aluminum is in period 3. So aluminum has 3 energy levels. So the maximum number of electrons that it could possibly hold would be 18. We know that that's not true because it only has 13, but it could, in theory, hold up to that 18. Step 2 is to write the electrons in the following order. Now, for a regular chemistry class, you will be given this chart. If this is an advanced placement class, this is something that we're going to look at in a little bit more detail. You will never be given this chart, so you have to kind of remember the order. There is a trick to that, which I can show you later. But for general chemistry, you'll be given this chart. So you always fill them in this way. So follow the chart. Follow the arrows. Notice that the arrows go from right to left and then back. Each line from right to left. So this way, and then the next one you do the same thing, back again. The next one you do the same thing, back again, all the way down. Okay? So it would go 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, etc., etc., until you get all the way to the end. Alright? Now, you might have noticed something kind of wonky. It goes 3p, 4s, then back to 3d. Well, there's a reason for that. And without getting into too much technical information, essentially, it requires less energy to fill the 4s subshell than it does the 3d subshell. So elements will often fill the 4s subshell, and the 5s, and the 6s, and the 7s, and the 8s, before they fill the previous d, and in other cases, F, orbitals. You just have to trust me that that's the way it goes. Alright, so we get to our final product. If I'm doing an electron configuration for aluminum, I'm going to tell you the energy level and the subshell and the number of electrons that are in each area. Okay, so those are the 3 things you have to have. The energy level, the subshell, and the number of electrons. So the very first one, according to our chart, is 1s. Now, aluminum has 13 electrons. The first subshell can only fit 2, so it's going to be full. So 1s2. 2, the first subshell of 2 is an s, so it's going to be 2s. And again, I have 13 to begin with. I've only used 2, so I've got enough to keep going. The next one is 2p, and of course, there's still lots of electrons, so I'm going to put a 6. I've used up 10 electrons. The next subshell to fill, according to the chart, would be 3s, and I've still got 3 electrons, so that is full. Then we get to our 3p, and there's only 1 electron left, so there it goes. And that, in a nutshell, is how you use subshells to write electron configurations. That's how you do it.